Hi everyone, I'm Ed Felten, Chief Scientist and co-founder at Off-Chain Labs, and I'm here to talk to you about Arbitrum. Arbitrum offers the advantages of Ethereum, but without the disadvantages. Arbitrum offers very cheap transactions because we move computation and storage off the main Ethereum chain. At the same time, Arbitrum is fully trustless. We offer permissionless validation, and our security is firmly rooted in the security of Ethereum. It's also drop-in compatible with Ethereum. We fully support the Ethereum virtual machine. There's one-click porting. You don't even need to recompile your code. And it works with all existing languages and tooling. So it's like Ethereum, compatible with Ethereum, only better. Arbitrum 1 is our mainnet. We released our mainnet beta in May of 2021, and our mainnet is opening fully to the public on August 31st. We're very excited that that's coming up so soon. Arbitrum comes with a big ecosystem. We have many infrastructure providers. You see here many of the largest, most important infrastructure providers have announced that they'll be working with us and supporting Arbitrum. Wallets integrated with Arbitrum, and many of the biggest and most important dApps also supported and integrated with Arbitrum. These are the providers and the dApps that have publicly announced so far that they'll be working with us. But there are many more. There are about 400 teams in our developer program. Let me talk a bit about how it works, because I know this is a community of developers. So the big picture of how Arbitrum works is very simple. The chain has an inbox where users can submit transactions. There's a chain state which is updated over time as the chain consumes those incoming transactions from the inbox, and then it produces a bunch of outputs like payments or events. So from this picture, to get to a complete system design, there are several types of questions that we have to be able to answer. Who keeps track of the inbox and the chain state? How do we ensure the chain state and the outputs are correct? How do users interact with the system? And how are ETH and tokens transferred in and out of the Arbitrum chain? I'll spend most of the rest of my time answering these questions and giving you a picture of how Arbitrum works. The first thing to talk about is rollup. Arbitrum is a rollup type technology. That means that users' transaction data is posted on the main Ethereum chain in a compressed form, but ultimately posted on the Ethereum chain. But execution and storage are moved off-chain into Arbitrum nodes. Arbitrum operates by proving the correctness of the computation that happens on the L2 Arbitrum chain is proven to the L1 chain using optimistic rollup technology. Basically, some validator makes a claim about what the correct outcome is, and then there's a fraud-proof mechanism that allows us to resolve any disagreements among validators. And all of this is secured by the layer 1 blockchain, secured by smart contracts running directly on Ethereum that are the record keepers and referees in the Arbitrum protocol. To give a picture of how the Rollup protocol works, here we see a series of rollup blocks that encode things that have happened on the Arbitrum chain. And all the blocks up through block number 92 have been fully confirmed and recorded on the L1 chain. Then Alice made a claimed block, rollup block number 93. And Bob ultimately disagreed with that by staking on rollup block 95. Now there's going to be a dispute resolution protocol between Alice and Bob, where Alice defends the correctness of her claimed block 93, and Bob challenges it. So how is fraud proven? How does Bob prove that Alice is wrong? Well, all of the inputs to transactions, as I've already said, are posted directly on Ethereum. And now validators like Alice and Bob make bonded claims about what's the correct result of executing those transactions that arrived as inputs. Invalid claims, if they're made, can be challenged by anyone, as Bob has challenged Alice's claim in our example. There's then, if there is a disagreement, a dispute, there's an interactive challenge to narrow down the dispute from a dispute about a large amount of computation to a dispute about a smaller amount of computation, smaller and smaller, until ultimately there's a disagreement about a single step of execution, and then a one-step proof procedure is used to declare the winner. It looks kind of like this. We start up at the top with Alice having made a claim, and her claim is that if assuming that the system starts with the hash of its state equal to h of s0 as shown on the upper left, Alice claims that the chain can execute n steps of execution, and after that the result will be h of sn. And she also claims that the chain will emit certain outputs. It'll make some payments and emit some messages. Bob says, no, that's wrong. Now, Alice then is required to divide her n-step claim into two claims that are half as large, two consecutive claims of size n over 2. And then Bob is required to identify one of Alice's n over 2 size claims as incorrect. In this example, Bob has challenged the second size n over 2 claim of Alice. Alice then has to bisect again, taking that challenged n over 2 step claim divided into two claims of size n over 4. Bob chooses one of those, and so on. At each round of this bisection protocol, we cut the size of Alice's assertion in half. So after about log n steps, Alice has made a claim about one step of execution, which Bob disagrees with. Now, Alice might then be challenged to prove something like, well, Alice has to prove the correctness of that. So Alice might try to prove that that's an add instruction, that the values being added are 3 and 5, and that the result of 8 is the correct sum. So that's an easy thing to prove. So we take a very large dispute over n steps, narrow it down to a very small and simple dispute, and on we go. Now, the beauty of this interactive proving scheme is that first of all, it's very efficient in the optimistic case. If Alice's claim is correct, then she's just posted that simple claim before hash, after hash, number of steps, and hash of the outputs. If that's correct, that's all she has to do. Alice will do that every, say, 10 or 15 minutes on mainnet, and everything is good. Super efficient. Even if there's a dispute, the cost to the L1 contracts is minimal. L1 contracts running on Ethereum act as the referee in this dispute protocol, but the referee's job is very simple, just to make sure that Alice has made two half-size claims without thinking about whether those are correct or incorrect. That's Bob's job. Make sure that Alice has broken her claim in half. Make sure that Bob has designated the first or second half, and so on. Very easy for the referee to do. You never need to run the full transaction on L1. You never need to take the full code of the contract and move it to L1. So it's very efficient. That means we can have much higher gas limits and much larger contract size limits than L1 Ethereum. We're simply not bound by Ethereum's limits because we never have to execute an entire transaction or store an entire contract at L1. This also gives us a ton of flexibility in how we implement the system and how we do the fraud proofs. And that flexibility pays off in performance and it pays off in compatibility. So we think interactive fraud proving, which is the thing that's special about Arbitrum, is a huge improvement over what other systems do. So if you're a user, you can take the L2 view of Arbitrum. That is, you simply view this as a chain like Ethereum. If you're a user, you can make RPCs to an Arbitrum node, and that Arbitrum node will then talk to ArbOS, and ArbOS is a component we wrote that runs at L2 and emulates EVM contracts. The user experience here is very standard. Arbitrum nodes provide a standard JSON RPC endpoint compatible with what Ethereum nodes offer. So it's compatible out of the box with MetaMask, Hardhat, and other standard tooling. If your tooling knows how to talk to an Ethereum node, then it can talk to and work with an Arbitrum node. Nodes always know the correct state. They don't need to trust individual validators. And users can deploy contracts. Because of the standard JSON RPC API, users can deploy contracts using standard developer tools like Solidity or Viper. As I said before, you don't even need to recompile. Now, the secret sauce that makes all of this work is ArbOS. ArbOS is the L2 operating system of Arbitrum. It's a mini operating system that runs at layer 2. It runs on top of the rollup chain. Because it runs at layer 2, it gets the advantage of very cheap execution and very cheap storage. That lowers the total cost of operation of the system by a lot. Instead of having a lot of complexity and cost in L1 contracts to enforce the rules of our rollup, we push as much as possible of that work up to L2 and put it in ArboS. That gives us speed, it gives us low cost, and it gives us a lot of flexibility, which pays off for users in many ways. So ArboS provides generalized, safe L1 to L2 transactions. L1 can call L2, L2 can call L1. It offers safe token bridging. You can move ETH and tokens back and forth smoothly. It offers efficiency features like batching of transactions to amortize the L1 costs, BLS signatures to lower the cost of signatures and make transactions even smaller. It offers EVM compatibility at the bytecode level. To deploy a contract, you send literally the same bits that you would send to Ethereum. And it's easily extensible with new transaction types and features. This, again, is a unique feature of Arbitrum that we think is really important in providing the value that so many developers are seeing in Arbitrum. So putting it all together, putting all those features together, you get back to this simple model of an inbox where users put in transactions, an execution engine, which is operated by validators, but which users can simply trust, or if you want to, run a validator yourself to execute trustlessly, and produces outputs that are compatible with Ethereum. Here's a picture of all of the pieces in our stack, Arbitrum nodes, ArboS, and then some contracts we call the ETH bridge that run on Ethereum. All of this is open source and available for you to look at. And it's been running on testnet since November and running on mainnet since May. So the next steps, well, come and hang out on our Discord, visit arbitrum.io and click join our community. You can view our developer documentation at developer.offchainlabs.com. And most importantly, deploy your dApps and use Arbitrum mainnet because it opens on August 31st. Thanks for your time. Please come to our Discord or reach out to me if you have any questions. We're really excited about the launch that's coming out, and we can't wait to have the broader community see what we've done, and most importantly, what our amazing community of developers and providers have done and are doing.